So the other topic that we are going to look at today is implicit differentiation. So you've learned how to do derivatives of a function where you have, y equals and then a whole bunch of x's in the statement, or, like f of x equals and then a whole bunch of x's. Implicit differentiation is for when the x's and the y's are sort of all mixed up together. So you don't have a clear-cut y in terms of x. They're all sort of jumbled. So the only thing you really have to remember, because none of the derivative rules have changed, like it's still product rule, quotient rule, chain rule, all the derivatives are still the same, like none of that is going to be any different. But you just need to remember that you have to do dy dx. It is the derivative of y with respect to x. So every time you do a derivative of a y variable, you're going to have to do this as a chain rule. It's a chain rule for your y variable. So you still want to do derivative of y with respect to x, but they're going to be all jumbled up. And basically, if your answer looks like a complete disaster, then you probably did this right, because they end up just looking like a jumbled mess. And you're going to see what I mean about this chain rule as soon as I do a couple of problems here. Y prime is also notation for a derivative. I recommend against that in this case. Write dy dx instead, because again, you're going to have x's and y's all jumbled together, and if your prime mark isn't clear enough, you're going to think it's a y instead of a y prime, and it just ends up being a total mess. So please write dy dx instead of y prime. It means the same thing. And it is going to be fun. Stop being such a Debbie Downer, okay? I can feel your sarcasm through the screen, all right? So first one, derivative of 3x squared is 6x, right, minus, now we're doing a derivative of y. So it's going to be a power rule. We're going to bring down the 2, so it'll be 4y to the first. And then you're going to do a chain rule for the y variable. So we're going to chain on dy dx. And if you're like, hey, Ms. Cole, I think I'm going to forget to put a dy dx there, you will catch it because dy dx is going to be your answer. When you go to solve for dy dx, if you don't have a dy dx in the statement, you're going to be like, oh, I need to put that somewhere because that's the answer that you're looking for. All right, equals. And then derivative of x is 1. So we did derivative of 3x squared, that was 6x, minus derivative of 2y squared, that's 4y dy dx, equals, and then derivative of x is 1. All right, and then what you need to do is get dy dx by itself. So the rest of this is just a whole bunch of algebra. So I'm going to minus over the 6x. So I subtracted the 6x to the other side, so I've got 1 minus 6x, and then we're going to divide by the negative 4y. And that would be your final answer. So again, if your answer looks like a bit of a mess, then you probably did it right. Yeah, it's a little bit of writing, but and it looks funny, but it's not necessarily hard. You're still just doing a derivative. All right, and I think I had number 7 kind of piggyback off of this one, so I'm going to copy this onto the other side of the paper, this 1 minus 6x over negative 4y. Number 7 says, write the equation of the tangent line for problem 6 at x equals 1. So you know what, I'm actually going to need the equation itself as well. So let me copy that too. I'm just going to copy this onto the other side of the paper. So 3x squared minus 2y squared equals x. So that was the problem we were given in number 6, and this is the derivative that we found. So I just copied that over so I could see it, so I don't have to keep flipping the paper over. And 7 is asking for an equation. So what two things do I need in order to write an equation? Again, it's been a little while since we've done this. And good, we need a point and we need a slope. Awesome. All right, so our point is going to be at x equals 1. That is our point of tangency. So 1 goes there. And so I'm going to plug 1 in for x in the original equation. So again, the point comes from the original equation. So I'm going to plug in 1 for x up here. All right, so 1 squared is 1 times 3 is 3 minus 2y squared equals 1. Again, I'm plugging in 1 for x. And then we're going to solve that for y. So I'm going to subtract over the 3. Again, this is really just a whole big bunch of algebra. Subtract over the 3. That's going to give you negative 2y squared equals negative 2. Divide by negative 2. That'll give you 1. And then square root. Technically, we would get plus and minus 1. Let's just do the positive 1 for this problem. Just for the sake of argument here, we'll just make that be a positive 1. All right, so that's our point. Slope comes from the derivative. Remember, derivative means slope. So here's our derivative. So we're going to plug in 1 for x and 1 for y to get our slope. So the numerator, if I plug in 1 for x, that's going to give me 1 minus 6. That'll be negative 5. And if I plug in 1 for y, that'll give me negative 4. And so the negatives are going to cancel, so 5/4. And so this is the point, this is the slope, and we'll just put it together into the equation. Y minus 1 equals 5/4 times x minus 1. Right, so the rest of these, we're just going to get the derivative. It's all just find the derivative. All right, so for number 8, derivative of 5y is going to be 5, and then you have to multiply on a dy dx. Again, anytime you do a derivative of a y variable, you have to chain rule on a dy dx. So this derivative would be 5, and then we multiply dy dx. Plus, right, this is going to be a product rule. X is the first function, y is the second function. So this is going to be a product rule. So product rule is the first, that's x, times derivative of the second. So derivative of y is dy dx. So that's first times derivative of the second plus the second, which is y, times derivative of the first, and derivative of x is just 1. So you can write it or not, it's just going to be a 1. So that was our product rule, equals derivative of x squared is 2x. So the calculus is done. That was all the derivative. Now we need to just solve for dy dx. So both of these terms have a dy dx in them. I'm going to leave them where they are and subtract this y to the other side. So we're going to have 5 dy dx plus x dy dx equals 2x minus y. So I just subtracted this one y to the other side. And then we're going to factor a dy dx out. So if we factor out a dy dx, it's just GCF, it's just greatest common factor. You would be left with 5 plus x equals, and I'm just copying the rest of that over. And then to get dy dx alone, you're going to divide this 5 plus x to the other side. So your final answer will be 2x minus y over 5 plus x. So I divided this to the other side. So again, it's just a whole big bunch of algebra. So if your algebra skills are intact, you're going to be just fine. It looks messy, but you're just rearranging things, really. Algebra is really just moving stuff. Like I'm going to move this to the other side of the equation, and then I'm going to move this to the other side of the equation. All right, so number 9. Derivative of sine is cosine. So this is going to be cosine of 4x squared. And then that involves a chain rule. What am I going to have to multiply on for the chain rule in this one, guys? What am I going to multiply on? I'm actually going to write it out front as the coefficient, but what will I have to multiply on here? All right, good, 8x, awesome. All right, so that takes care of this first part. Minus, all right, derivative of cosine is negative sine. So the negatives are going to cancel. So this will be sine of 5y. And then I have to chain on the derivative of 5y, which is going to be 5 dy dx. So I'm going to put the 5 out front as the coefficient and just multiply on the dy dx at the end. Again, anytime you do a derivative of a y, you have to multiply on a dy dx. And to be real honest, this usually all goes okay. And then people will stumble over the 9. They'll write equals 9. It happens. Try not to let it happen to you. Remember, you're doing a derivative. So what is the derivative of 9? Yeah, good. It's going to equal 0. It happens all the time, and I always feel so bad because I get why it happens. You just see that 9 and feel like you're done with the problem, and so you just write 9. Remember, derivative of just a number, derivative of a constant is going to be 0. So that's all the calculus. Now we're just trying to get dy dx by itself. I'm going to subtract all of this over. So this is, you have to not be lazy because this is a good bit of writing. I'm going to subtract this to the other side. So it'll be negative 8x cosine 4x squared. And then the last step to get dy dx by itself, you're going to divide all of this to the other side. So actually, if you do want to just go, okay, divided by 5 sine of 5y, and then scratch this out, I'm good with that. I will totally accept that answer if you don't want to recopy it. The thing with recopying a lot of times is the more times you copy something over, the more likely it is you're going to make a copy error, and that's just a real bummer if you copy something over wrong. And these problems in particular, it's likely to happen, so just be careful. All right, number 10. Derivative of 5e to the y. Well, that would be itself. It would be 5e to the y. But we're doing a derivative of a y variable, so I have to multiply on dy dx. So it's 5e to the y. It's just itself. I just copied over the problem, and then times dy dx. Plus, derivative of 3x would be 3. And then equals derivative of y is dy dx. All right, so I need to get dy dx alone. I have 2 terms with a dy dx in it. So first I'm going to have to get them both on the same side. So I'm going to subtract over this first term. So we'll have 3 equals dy dx minus 5e to the y dy dx. And then I'm going to factor dy dx out. So it's a greatest common factor. Now be careful here. When you divide out dy dx, for this first term, you're going to have a 1 there. So this will be 1 minus 5e to the y. And then your last step, you're going to divide all of that over. You want dy dx alone. So your final answer is going to be 3 divided by all of this. All right, so number 11. Derivative of x to the 4th. That'll be 4x cubed plus, all right, 10, and then derivative of ln is rational. So it's going to be 10 times 1 over y. So this will be 10 over y, and then dy dx. Again, anytime you do a derivative of a y variable, multiply on dy dx. Plus, All right, derivative of y squared, that's going to be 2y dy dx, and then derivative of 0 is 0. So now we need to get dy dx by itself. So these two terms have a dy dx. I'm going to subtract over the 4x cubed. All right, so I just subtracted the 4x cubed to the other side, and then I need to factor a dy dx out. So it's a greatest common factor. So if I factor that out, I'm going to be left with 10 over y plus 2y. And then last step, I'm going to divide all of this stuff to the other side. And yes, I will have a fraction in a fraction. That's okay. Don't let that bother you. You're better off just keeping your hands off than trying to mess with it, because again, if you mess with it and you make a mistake, then it's going to be wrong. So just leave it alone. All right, and then this last one, hey, this has a bunch of 2's in here. What does that mean that that's asking for? What does this notation mean the question is asking us for? Yeah, good, nice job. Second derivative. All right, so we can't jump straight there. We're gonna have to get the first derivative first, and then we'll go and get the second derivative. Nice job, guys. All right, so derivative of y cubed, that's gonna be 3y squared dy dx. So 3y squared. Oh, I am the worst speller. Have we talked about that in this class? We probably have. Please do not worry about how you spell anything. I am like the worst speller imaginable. I have a complete math brain, and so spelling is like, I mean, I'm not trying to say that spelling isn't important. You should be able to spell stuff, but like I will never hold you accountable for that, because I'm a awful speller. All right, 3y squared dy dx equals derivative of x squared is 2x. And then we're going to divide over the 3y squared. Yeah, I pretty much rely on like when you go to search something in Google, it'll just finish spelling it for you. Whoever invented that, they're my hero. All right. So anyway, back to this. We divided over the 3y squared. So this is our first derivative. All right, so when we go to do the second derivative, it is going to involve a quotient rule, because we have a fraction here. So this is going to involve a quotient rule. And you know what? I've written too big. Let me just get another piece of paper. I wrote too big on this one. I don't want to make it super cluttered so you guys can't see what I'm writing here. All right, so the second derivative is going to involve a quotient rule. So quotient rule is the denominator, so that'll be 3y squared, times derivative of the numerator, so derivative of 2x would be 2, minus the numerator, times derivative of the denominator. So derivative of this would be 6y dy dx. And then it is all over the denominator squared. All right, and here's the one thing that we are going to have to fix up. You can't leave this dy dx in there. So we are going to replace this dy dx with this statement. That's what dy dx equals. So to not have to rewrite this, I am going to just erase the dy dx and put the 2x over 3y squared. I guess I could have fit that on the paper. I just didn't want to try and have it be like super tiny and messy. And there is a good bit of simplifying you could do to this, but my suggestion is hands off. Unless it's multiple choice and you have to keep going to figure out what your answer choice is, I would just leave it alone. That is my recommendation. And wait, let me see what the question was. Oh, yes, and to answer your question, yes, we replaced dy dx with this statement right here that we got for it.